Thanks for watching my video today. Let's try to evaluate one limit. Okay, then is limit n tends to infinity n over n square plus n over n square plus 1 square plus n over n square plus 2 square plus and so on plus n over n square plus n plus 1 square. Okay, here you can write in here. Okay, now our solution, let me call our limit to be L. Okay, L equal to limit n tends to infinity n over n square plus n over n square plus 1 square plus n over n square plus 2 square plus and so on plus n over n square plus n plus 1 square. This one I can write in as 0 square also. Okay, n square plus 0 square, right? Now this is a summation, so let's put in summation sign. So limit n tends to infinity, the sum from r will goes to 0, right? 0 to n plus 1, n over n is the same thing upon n square plus r square, right? Here the only chance is this one, r is changing, right? Then is it start from 0 to n plus 1, right? So which is limit n tends to infinity, sum from r equal to 0 to n plus 1. So simplify this, n over, now let's take n square to be common. So n square, if I take common here, it will be 1 plus r square by n square, right? Now this n, this n will be cancelled, so you get limit n tends to infinity, sum from r equal to 0 to n plus 1, 1 over n, 1 plus r square by n square, right? So that these types of limit I have already solved it, how to change the limit into definite integer. Okay, so when r tends to 0, so when r tends to 0, what will happen? R by n will tends to 0, right? And when r tends to n plus 1, then r by n will tends to 1. Why? Here is the proof. So limit n tends to infinity, right? This limit n tends to infinity, n plus 1 by n, which is limit n tends to infinity, 1 plus 1 over n. So this will be just 1. So, or this limit now change. Now replace this limit and summation by this integral. Okay, this integral, and the sum from r equal to 0 to n plus 1 will change to 0 to 1 here, right? 0 to 1, and 1 over n will be dx, and this is 1 plus r by n will be x, right? X square. So this will be, this is nothing but tan inverse of x from 0 to 1. So our limit L to be tan inverse of 1 minus tan inverse of 0. This is pi by 4 minus 0. Therefore our L is nothing but pi by 4, meaning our L is nothing but our original limit, right? Therefore limit n tends to infinity, n over n square plus n over n square plus 1 square plus n over n square plus 2 square plus and so on plus n over n square plus n plus 1 whole square, which is pi by 4. So this is the limit, and you can check out for this one. Okay, how to change this limit into integer.